The Issaquah School District was confronted with a major problem for their administration offices and an existing elementary school. A 20-year-old asphalt parking lot had failed and required complete removal and reconstruction. Preventative maintenance and early repairs were often driven by unavailable funding and small budgets. The parking lot had deteriorated beyond its useful life of 15 to 20 years, and complete removal, over-excavation, and replacement was the only asphalt solution available. Fatigued and brittle, the asphalt lot exhibited severe alligatoring, extensive subgrade damage due to water intrusion, and a failure to carry the repetitive load of 18 school buses per day per school year. Previous patching treatments or even a complete overlay would no longer provide an effective Band-Aid repair. The district was now faced with a $350,000 asphalt solution and a $270,000 budget. The local ready-mix concrete supplier presented the school district with a different approach to traditional asphalt repair: concrete whitetopping, a concrete pavement placed directly over the failed asphalt. Concrete's ability to provide excellent structural quality and superior load transfer over poor subgrades made concrete paving a viable and economical alternative to the complete removal of existing asphalt sections, plus over-excavation, hauling, and disposing of asphalt debris and reconstruction. The Issaquah School District agreed, and concrete paving was approved as an alternate paving medium. On bid day, 4 bids were received for the 122,000 square foot project, 2 asphalt bids and 2 concrete bids. A year earlier, in 1989, the project was bid but not awarded because the low asphalt bid was $350,000, $80,000 over the funds available for the project. The asphalt sections were 2 inches of Class B asphalt, over 4 inches of crushed rock, over 5 inches of drainable fill, placed over a filter fabric for automobile areas, and a 3 inches of Class B asphalt, over 6 inches of crushed rock, over 5 inches of drainable fill and filter fabric for bus lanes and main drive areas. A deductive alternate of marginal asphalt sections of 2 inches of Class B, over 4 inches of crushed rock, and 3 inches of Class B asphalt, over 6 inches of crushed rock, were included to protect against another over-budget scenario. The concrete whitetopping section to be bid was 5 inches of unreinforced concrete for automobile areas and delivery refuse vehicle areas, and 6 inches of unreinforced concrete for school bus driving and staging areas. On the bid due date, the following bids were tendered. Asphalt bid number 1 was $355,000. Asphalt bid number 2 was $264,000. Concrete bid number 1 was $282,000, and concrete bid number 2 was $278,000.
The use of concrete to overlay an old failed asphalt parking lot is a very logical way of construction, but it is not often considered. The design of the concrete pavement section does not require any special or unusual design methods. It is a very straightforward method, only requiring the information needed for a typical design. Although the asphalt was cracked and failed, it still provides a relative uniform and stable base for the concrete overlay. The subgrade support value, or K value, we selected was 100, a conservative value. Working with the school district, we defined the bus traffic and the bus's weights, as well as other miscellaneous trucks. A 20-year design period was specified by the district. This data was then put into standard design methods, and for the parking lot area, we came up with a 4-inch thick section, although we increased it to 5 inches to carry the occasional truck traffic we knew that would be on it. For the access roads carrying the buses and all other traffic, the design required a 6-inch section. However, this section also worked for a 30-year design period, so the school district was getting additional life at no additional cost.
Concrete paving would provide the school district with a 25 to 30-year serviceable life, while asphalt remained a 12 to 20-year option. Concrete paving also provided positive site drainage with existing minimal catch basins. Concrete provided a 25 to 30% increase in exterior lighting efficiency for nighttime security and visibility. The concrete bid was site-specific to anticipated bus traffic and known site conditions. The concrete bid also included a 3-year warranty compared to the typical 1-year asphalt warranty. And finally, concrete paving represented no future parking area maintenance expenses. Concrete paving is virtually maintenance-free. After careful study of both the asphalt and concrete alternatives, the school board chose concrete whitetopping, Meidling Concrete of Spokane was selected as the general contractor, and Cadman Premix supplied the concrete. The concrete challenge was on. Only 2 months were available for total project completion during summer vacation. The construction sequence for concrete whitetopping required only the removal of 300 cubic yards of existing asphalt and subgrade compared to the 1,500 cubic yards of material required to be removed in the total asphalt reconstruction. Because of severe settling and undulation of the existing asphalt profile, a 1-inch layer of crushed top course was spread over the project to provide a level paving surface and to eliminate existing potholes and alligated areas. Concrete paving lanes were established for efficient and economical placement and paved alternately in 24-foot and 20-foot wide widths. Meidling Concrete used a standard vibratory air screed and a bunion striker tube to place and compact the concrete. The concrete was then bull floated and a skid-resistant textured surface was provided by a burlap drag. Crosswalks were stamped to provide visible and permanent safe areas for children to cross and enter the school parking areas. A careful and detailed joint layout was supplied by the contractor and employed the use of a short joint spacing to eliminate the unnecessary expense of wire mesh. Number 4 tie bars were installed along the centerline longitudinal joint for the bus drive lanes. The contractor elected to saw cut transverse and longitudinal joints with standard saw cutting equipment, and also used a soft cut saw for green cutting of control joints in the fresh concrete pavement. Finally, a white pigmented curing compound was applied over the concrete 3 to 4 hours after placement to protect against moisture loss from the concrete.
We knew that we could be competitive on the project. Considering the demolition and the disposal of the asphalt, we were able to not only be first cost competitive, but then when the district considered a life cycle cost analysis, we were providing a project that gave probably a 25 to 30-year life as opposed to an 8 to 10-year life. Probably the most critical element in construction and design because of the overlay was the grade. Because of environmental concerns, we only had a few catch basins throughout the site. And so it was very important to maintain a high quality of construction and carefully control our grade to make sure the drainage worked. As the district opted not to replace the sidewalks, it was necessary to take into account the transitions from the sidewalk onto the parking lot area. As you can see here, we went with the top set curb. This turned out to be a very advantageous project for owner, contractor, and supplier alike, and Meidling Concrete was very proud to be a part of it.
Over 2,000 cubic yards of concrete was supplied by Cadman Premix using a standard 4,000 psi, 5.5 sack, air-entrained concrete mix delivered locally and achieved well above the specified design parameters. Traffic was on the pavement in 3 days or less.
The concrete produced for this project by Cadman Premix Company of Issaquah, Washington was a standard 5.5 sack, air-entrained 4,000 psi mix. Because the concrete was placed at a relatively low slump at a low water cement ratio, early strength gain of 3,000 psi in 3 days was attained easily. This strength gain was adequate to maintain the construction sequence schedule Meidling Concrete had established. Our quality control representative was available at the site to correlate slump, air, and cylinder tests with the owner's representative. Whitetopping projects, as well as all concrete paving projects, are a high priority with ready-mix concrete suppliers. The short unloading time, coupled with relatively large volume placements, provide the opportunity for very competitive prices as well as attractive returns for the concrete producer.
The results of the actual site and traffic pavement design and the teamwork effort for a long-term, high-quality parking area resulted in the Issaquah School District's accomplishment of meeting its construction schedule and budget. The Issaquah School District now owns an investment against future parking area maintenance and a project that will last a lifetime.